Okay, this is going to be the Unit 1 review video for Algebra 1 for 2020. The numbering, don't worry about it doesn't go in exact order. This is just going to go into some general concepts. First thing we're going to talk about is how to evaluate an expression. Okay, you want to keep in mind about PEMDAS, okay, all right, and trying to apply that, all right, parentheses, exponents, multiplication, division on the same row, addition, subtraction on the same row, okay? All right, for this we can do some substitution, okay? We can use our calculator for this, okay? So what I want to do, all right, I would want to substitute in 4 for x and -3 for y, all right? So 4, arrow, alpha, just got to find the x, which is right here, and then hit execute. And I do -3, arrow, alpha, find the y, which is right here, then execute. And I'm just typing in the expression, 3, alpha, x, do the exponent for cubed, minus alpha, y, exponent squared. So the first answer for that first question is 183, okay? For 14, okay? All right, now, what we want to consider is we would want to do this operation first, okay? We want to do that operation first, all right? So let's do -8, arrow, okay? Alpha, m, execute, and we got n is 2, so 2, arrow, alpha, n, execute is that. So I want to do m, alpha, m, divided by 2, alpha n. Okay, I get that, and then I want to add 7. So I just hit add 7. I get an answer of 5. Okay, all right. I want to keep in mind that we want to do the exponents first here. All right. So this is some decimals, but nothing's going to change. 2.5 arrow, alpha a, execute. Okay, b is 1.7, so 1.7 arrow, alpha b, execute. All right, I want to handle that part first. Alpha b plus 3 alpha a. Okay, so that result there, 9.2. Okay, and I'll handle this 3a squared over here, 3 alpha a exponent squared, so 18.75, and then I'm subtracting those. So the answer for this one is 9.55. Okay, want to handle this stuff inside first. So with the fractions, okay, this isn't overly that complicated. What I want to do is I'm going to do parentheses 4 divided by 9, close them. Then this arrow, then alpha a. I'm sorry, alpha p. So A, B, C, let's find the P right here, all right? Alpha P, that's where the 4 is. And then I want to do 1/3 for Q. Okay? All right. So then handle this part first. Alpha Q plus 6 alpha p, parentheses, squared, okay, gives me 9, okay, I'm going to figure out the square root of alpha p, minus 9, okay, that's your decimal, -8.3 repeated, okay, moving on, all right, an evaluated expression gives the number of points, okay, it gives the average number of points earned in D games by winning an average of A games in regulation, B games in overtime, and C games losing in overtime. What is the average number of points earned for each team? Okay, if 10 games in regulation. So what you're doing here is applying this concept. Okay, all right. So all right. So what we want to do is we want to substitute these results. Okay. losing C gains in overtime. So they tell us I have 6 overtime losses, so that would go here. Okay, 8 wins in overtime is B. All right, so the B is 8, the C is 6. Okay, all right, and then 10 games. A represents winning 10 games in regulation. Okay, and D represents losses in regulation. Okay, all right, so what I want to do, all right, is I'm going to go ahead and substitute those values in. Okay, all right, A is going to be 10. B is going to be 8. C is going to be 6. Oops, just going to hit execute there. Oops. 8 arrow alpha B. C is 6 arrow alpha C. Okay, and then D is 4 arrow alpha D. Okay. All right, let me just make sure I put A in there. 10 arrow alpha A. All right, just so I got everything in there. Okay. All right. So what I want to do, and this is from an order of operations, I want to start with that part first. So I'm going to do 3 alpha A plus 2 alpha B plus C, alpha C. Okay. The top number would be 52. The bottom number, which would be 4, would be there. So I want to do 52 divided by, you can do 52 alpha D and come up with your answer, or you could do 52 divided by 4. Either one would be acceptable. Answer's 13. Okay, I know it's a little bit small. It says translate the following into a verbal expression. So this is multiplication, so I would say -4 times, all right? All right, you can do a couple different things there, but you could say times the sum of x and 3, okay? All right, you could also say times the quantity of x and 3, okay? So this one, it shows you 2 different ways to write this. I would write this as 4 less than, remember we talked about this in class that when you do the less than, it basically flips that around. 4 less than the square root of x, okay? Now the difference with this one is, this would be the square root of the difference of x and 4, okay? So somebody say, well, Mr. Evans, why don't you write the 4 second? Well, when you do the and, you can keep them in the order. When it's less than or more than, they switch around. Okay, the difference between a number and 5. Okay, so what that would be is the difference between a number and 5 and minus 5. If it would have said, like this one says 5 less than a number, okay, 5 less than a number, okay, that goes that way. Even though the 5's first, the less than is like the more than, it flips around. A number less 5. Okay, actually, hold on, that's not right. Let me erase that. Okay, another way to write this number, less 5. The difference between 5 and a number. Okay, difference between 5 and a number. Okay, so when it's a difference, it's in that particular order. Okay, right now, the great expression for each verbal expression. Okay, the product of the cube root of 5 and a number. All right, so the product of the cube root, all right, of 5 and a number. All right, so cube root, all right, okay, so the product of the cube root of 5 and a number. Okay, actually, I'm sorry, that's going to be all underneath here. Okay, the quotient of a number cubed, okay, and 5. The quotient of a number cubed and 5, or you could write it as cube root of n divided by 5. Okay? All right? 14 more than the product of a number and 6. So 14 more. That more than flips that around, so that's over here. The product of a number and 6. So this would be like 6n. 3/4 of the difference of a number w and 7. Okay? So what this would be is 3/4 of means multiply. Okay? The difference of a number w and 7. Okay? So it's like that quantity deal. All right? 9 divided by 2 plus the product of -5 and a number y. All right? So 9 divided by 2 plus the product of -5 and y. So you can do it as -5 times y, or -5y. All right? 3 times the sum of, okay, so 3 times the sum of 4.6, 5.9, and a number z. Okay, so that's a quantity time. Anytime you have 3 times, as you can see, this of, that's referring to a multiplication symbol with a distributive property. Okay? All right, moving on to the next part. Okay? James simplified this. Okay? All right? So what he's doing is he's trying to group like terms. Okay? So the 16x and the x would be grouped here. Okay? All right? The 8y squared, or 8x squared y should link with this 10x squared y. Now, we'll see what he ends up deciding there, okay? And then this -7xy squared should be with this 5y squared, all right? So what I would have would be 16, and that which would be 17x. This would be this with this, so that's 8, okay, plus 10. So that should have been 18x squared y. Then these of -7 plus 5x. So that should have been -2, okay, xy squared. Okay, and then the last one, which was 9, and that, so those would just be 9 minus 7. So as you notice, what I'm doing is I'm just looking at the coefficients. I'm keeping the exponents the same. When you're adding and subtracting, you don't change the exponents. Now, look what he got for an answer. Now, what did he do wrong? Okay, what he did is he treated these all as the same. They're not. So, so this is the correct answer. All right. What he did was, the mistake was incorrect like terms. Okay, incorrect like terms. That was the mistake that he made. Okay, now we're moving on to these distributive property questions. Okay, all right. So what you're going to want to do is you're going to take this and we're going to multiply. So -10 times 10 would be -10. Okay, -10 times -9. All right. You know, use your calculator if you need to. You can use the Desmos calculator. So that's going to be 90x. Then I take 6 and multiply. So 6 times x would be positive 6x. 6 times -10, I treat that like a negative. So 6 times -10, all right, it's going to be minus 60, okay? Now, my x's are alike. So that's 90 plus 6 would be 96. Then I got these numbers. I got -10 minus 60. Don't put any extra signs. Just type them in like you see them, so it gives you the final answer of minus 70, okay? All right, and then what I want to do is this one. It's the same thing. I'm going to multiply. -3 times 10b would be -30b. -3 times 10 would be -30. Then we'll take this 5 and multiply. That's 5 times b, which is 5b, and 5 times 2, which is 10, okay? The b's, okay? So what I want to do is I'm not going to change the exponents. I'm going to do -30 plus 5, which gives me -25b. Then I got -30 plus 10. which is negative 20. Okay, all right. This one I'm going to do 5 times. 5 times negative 2 is negative 10n. 5 times 4, which is 20. Then I'm going to take this 2 and multiply. 2 times n would be 2n. 2 times 3 would be 6. Okay, so these would combine. Okay, negative 10 plus 2 would be negative 8. 20 plus 6 would be 26. Okay, all right. This one, I take negative 7 times that would be negative 7n. Negative 7 times 3 would be negative 21. Now, this is where you need to be careful. I have to treat this like a negative, okay? So what I'm going to do is I'm going to do negative 8 times 1 and negative 8 times 8, okay? So what I would get there is negative 8 and negative 64n. Okay? The n's, all right, I'm going to combine those. Negative 7 minus 64 is negative 71. Negative 21 minus 8 is negative 29. Okay? And that would be my answer for that question. Okay? The last part of this is going to be on properties, okay? And linking property examples, okay? All right? So this one, all right, since it's itself, this is an identity. Okay, because what happens is when you're adding 0, it ends up being itself. So that is the additive identity. That is going to be letter E. Okay, now this one, the parentheses are, if you can see, nothing changes, but the parentheses move. This is called the associative property. Okay, all right. Now this one looks like this one, except these are opposite. So when they're opposite, we consider that the inverse. So that, since they're adding, that would be the additive inverse, which would be H. This, if you look at these are just flipping around. So this is commutative, okay, which would be letter A. This also, when they're being multiplied, these are opposites. So this is going to be the multiplicative inverse, okay, because those are opposites. This is also an identity, as you can see, all right. This is itself, okay, when it multiplies, so that's the multiplicative identity, which would be F. Okay, all right. This is, you can see, this is like associative, except we're using addition, because if you notice the parentheses move. Okay, so this is the associative property of addition, which would be C, so that's associative. This is the commutative, because this one flips around, so this is the commutative property of multiplication. So this is associative. Okay. This is commutative. Okay. Now, you got this parenthesis, and we work this in the last thing. As you can see, they're being multiplied. So this would be considered the distributive property. Okay. All right. And going on to some of the last examples here, just more property stuff, some different justification. Okay. All right. So if you can see, these are being added, they're opposite, so this would be the inverse. It's inverse addition. Okay? This one is being multiplied, okay, all right, by negative 1, okay, which I believe that would be the identity property of multiplication, okay? All right? So this is identity. Of multiplication. Okay, this one, as you notice, the parentheses move around. So this will be associative addition. Okay, all right. This one just flips around. So this would be commutative. And it's multiply. Okay, this one, as you can see, they're distributing it because it's the multiplication, so you got distributive. This one, all right, this one is an identity as well, because if you're noticing, okay, it ends up being the same thing, so this is going to be identity of addition. Okay, this one, 1 times this equals that, that's just going to be the identity of multiplication. Okay, this one, the parentheses are moving around, so this is just going to be the associative of addition. Okay. All right, this one, as you can see, it's flipping around, so that's going to be commutative of multiplication. Okay, moving on to this. This one is flipping around. That's commutative of addition. All right. The parentheses are moving around here, so this is associative. Okay, with multiplication. Same thing. When you get the same exact thing, it's like a reflection. We call it the reflexive property. Okay. This is 6 times 1, 6. This would be inverse when it's multiplication. Okay. This right here, as you can see, they're multiplying out. That's the distributive. Okay. Sorry if I lost you there on that. Okay. All right. So just to run down. Second one was identity. Third one was associative. Fourth one was commutative. Fifth one was distributive. Sixth one was identity. Seventh one was also identity of addition. Eighth was associative. 9 was commutative. 10 was commutative. 11 was associative. 12 was reflexive. 13 was inverse. 14 was distributive. And now we're on to 15. Okay? All right. So 15 will be, looks like the parentheses are just moving, so that's going to be associative of multiplication. And the last one, the only thing that's moving around is that's going to be commutative addition. Okay? So that just gives you enough practice to be able to identify them. That's what you got to be able to do, is just to identify the properties. If you practice that, you practice your formatives, you should be good for the summative.